Welcome back to Theya. Today I'm here with a very special guest. You know him as Plan G, but his real name, is Giovanni Santostasi. He is a PhD in astrophysics and, of course, the father of the Bitcoin power law theory. Giovanni, thanks so much for coming on.
Oh, my pleasure.
Absolutely. So first things first, I guess. Why don't you go ahead and introduce yourself? You recently blew up on the Bitcoin scene with your power law theory, with the other work that you've done, and I've personally been very interested in diving into a lot of it. But for viewers who might not be aware, please introduce yourself and a little bit of your background.
Yeah. So I am a scientist. I have a PhD in physics, in particular astrophysics, and I have worked in the field of physics for many years. I was at that point a college professor in a small college for about 10 years. And Also during the time, this was during the financial crisis in 2008. There were a lot of things happening in the world. Actually, coincided also with some personal situations. I had to leave a university where I taught, and also I kind of recreated myself. Reinvented myself, so I changed field from physics to neuroscience, and then I went to Northwestern University and did some research there. I got some IP about an invention to improve memory and cognition, and then I wanted to commercialize the invention. I went to San Diego to create a startup, to commercialize this IP. And I tell you all this because the relevance of these changes in career is that it allowed me to see many different fields of science in using the same approach of physics. So there is a big change in going from physics to neuroscience, and at the same time, actually, the same thing that I did with Bitcoin, using these tools of physics and mathematics, helped me a lot. It's one of the reasons why, as a newcomer, I was able to get very quickly actually an IP in the field, because it was almost like a low-hanging fruit, where by looking at things in a different way, using the approaches that are very common in physics, I was able to do a lot of progress. So eventually, I applied the same principle and the same idea with Bitcoin. In fact, my story with Bitcoin starts around 2010, when I heard it for the first time. I downloaded the wallet. I didn't do anything with it. I was thinking, oh, this idea of mining on your Bitcoin, because at the time you could mine Bitcoin in your computer. I almost basically immediately understood the importance of Bitcoin. It's just how important it was. It took me a little bit of time, but I never understood. People would say I never understood. I didn't get Bitcoin the first time. I got it, and but I didn't act as quickly as I should have acted. But then in 2012, so basically I put it in the back burner. Like I'm going to. It was a little bit complicated at the time to set up your wallet, making it mine, etc. So I still have that computer as a reminder of how stupid I was that I didn't act when I downloaded it, in 2010. But then in 2012, I read an article in futuristic, people that are interested in the future, futurist kind of newsletter. And given that these people understand technology, are interested in future technology, they were really praising Bitcoin and telling, in a language that I could understand, all the characteristics of Bitcoin. And if I already was convinced before, this was the element that allowed me to really jump in. And in the end of the article, there was also a little chart that showed this little information that we had at the time, because this was 2012, so we didn't have a lot of data, but it showed the behavior of Bitcoin in a mathematical fashion that attracted me. And in fact, even before I bought Bitcoin, I tried to confirm what this guy was saying. He was saying two things. He was showing this bubble that happened before the halving, before we had any halving at all. And it was, at that time, there was a lot of talk about Bitcoin being tulips, that it was like a bubble that it was going to inflate and then explode, and then then basically zero from that moment on. And his argument was, it's not the case because you see we had our bubble, but then if this entire phenomena was a bubble, we will not continue to go up, and we continue to go up after the bubble. So it was interesting. And second, he was showing the general trend, if you kind of ignore the bubble, was very regular, and he called it exponential. But I went and analyzed the data, and it didn't look exponential, but it looked regular. So I was curious enough, I was convinced by the technology, and so I jumped basically in in a big way. And Bitcoin since then has been like a key element in my life, notwithstanding all the different things that I did, all the different changes. I always had Bitcoin in the background of my life since then, being like a big important part of my life, my interactions with other people in trying to understand the world. But my approach being a scientist has always been, I want to understand it from a scientific point of view. I want to understand these irregularities that I'm observing. I want to understand why Bitcoin behaves in a certain way, because to me that is a key element. If you don't understand it, if you don't understand that Bitcoin is just not an asset, it's something that has its own way of being and behaving, then you don't understand Bitcoin. It's that clear to me. And you don't have to understand it in all the details when maybe a physicist will understand it, but at least to understand that it's a very precise mathematical entity, that it behaves more like a natural law than an asset. Even today, somebody was telling me, this is just a model. It's not a model. What we are doing, the work we are doing, is much deeper than that.
Agreed. And I think that also, I don't know if you've heard this particular phrase, but a lot of people say Bitcoin was discovered rather than created. And I think that kind of, it lines up nicely with what you said, and that if you're viewing Bitcoin as, a model or a unique asset, you don't really understand it.
Exactly. So, in fact, one of the things I always say is that my work, in a sense, is proving mathematically and physically, scientifically, a lot of the things that a lot of people say about Bitcoin from an intuitive point of view. Sailors say certain things, like he talks a lot about energy, he talks about thermodynamics, he talks about Bitcoin being a city, etc. I'm actually showing mathematically that this is true. So a lot of things that people already say about Bitcoin, I'm actually saying, okay, here it is, the evidence from the data, and here how it works mathematically and physically. So I'm not discovering anything really new, in the sense that it's new and it's interesting and profound, but at the same time it aligns with a lot of things that people associate with Bitcoin. So, and it makes me a little bit sad sometimes when people resist it, because I can see a lot of resistance too, because actually it's kind of confirming what we like about Bitcoin. A lot of the properties that we like about Bitcoin. So yeah, it's much more than, it's a philosophy. It started to become a philosophy of Bitcoin that is actually based on science and math and data. So it's much more than a model. But anyway, this is an introduction about myself. So, and I call it a theory because, like I was telling you before, even before I joined Bitcoin itself, right, I wanted to understand it, and I wanted to study it mathematically, because even if some people they claim, I'm not focused on the price. Well, the price, it's like a very important piece of data about Bitcoin, because it actually contains a lot of information that allows us to understand how it behaves. But we don't have only price in terms of understanding Bitcoin. We have so much information from the blockchain. This type of data is called on-chain data. So you can learn about the activities in Bitcoin in terms of transactions, how many addresses are produced. That is another it's kind of like a proxy for adoptions of the users. You can learn about how much energy is consumed in terms of running Bitcoin through the hash rate. You can learn about how people hold their Bitcoin, because you can select certain addresses that have a certain history, that have lasted a certain amount of time. So you can learn almost everything about Bitcoin by studying the data. And to me, that is the approach that I follow, because as while many people have a very strong intuition about the nature of Bitcoin, the importance of Bitcoin, what is the role of Bitcoin in society, or what is going to be in the future, many people do improvise, right? So they have a strong intuition. At the same time, the other aspects of that is making things up in a sense, right? Because they have maybe a certain background, maybe because they have a certain point of view, a certain worldview, and so everybody, and it's great. It's one of the great things about Bitcoin, because you can it allows many people from different backgrounds. You can be from the left, you can be from the right, politically, you can be religious, non-religious. Like, it's one of the beautiful things about Bitcoin, because in fact being like a let's say an influencer in a certain sense, or a person that does a lot of activities in the community of Bitcoin, and it's interacting with a lot of people. I am fascinated by meeting a lot of people that have a very different background from me, But I love it, because I think it's one of these things that unified us beyond our worldviews, more than probably many other things that people are passionate about. And we should keep it in that way. We should be very tolerant to people from every origin, every group, every way of thinking. If we agree on what money is and the function of money and where we are going with that, it's more than enough. But also it's important to look at reality, because if you are a Bitcoiner, we always say, don't trust, verify, right? So it's all about verifying. It's all about being with the feet on the ground. Maybe your head can be in the clouds, and you can imagine all kind of interesting scenarios for the future, but at the same time it's very important to be grounded, and the data is what grounds us, so that is one of the things I want to emphasize very strongly. Many times I have discussions with people. They say, oh, Bitcoin is going to do this, Bitcoin is that. I say, well, let's look at the data, let's see what the data tell us, because the data is the ultimate truth. Now, data needs to be interpreted, right? That is also the other important aspect. But if you start with looking at the data, then the interpretation is guided at least by reality, and so that is my main approach here. I'm looking at the data from Bitcoin, so all the different data that we have from the addresses, from the hash rate, from the price, and then I put it together. So initially, I had the pieces of this understanding based on data. I started to look at patterns, and for example, I started to plot price versus addresses, or addresses in time, and all kind of different things, to trying to understand if I could see a pattern. And finally, after I had a big breakthrough, so I started with, in 2012, one of the first results was I could see that there was a very precise pattern between from addresses and price. And it's what is called a power law. A power law is a very simple relationship between two quantities. We will discuss it in the slide. But it was clear from the beginning there was some kind of pattern, some kind of regularity, and I reported this. And one of the things I did, different from many scientists, in fact, there are other scientists that started to treat Bitcoin like a science, and they even publish papers. There is a famous physicist name is Sornet. He's a French physicist, and he published already 3 papers, all scientific papers about Bitcoin. I was reading yesterday another paper that was discussing Bitcoin in Nature, that is one of the most important science journals in the world. So there are many scientists that are studying Bitcoin from a scientific point of view. My approach is that I try to interact with the community. So one of the things I did when I made some important discovery of Bitcoin, I will post on Reddit, for example. And one of the posts that was essential in this history of how I discovered property about Bitcoin was in 2018, when after trying many different things, I actually tried to plot directly the price with time, because really these are two fundamental elements. And even if you want to dismiss the price, like, okay, I'm interested in Bitcoin as a general technology, as a general concept, I'm not focusing on the price, it's still a very fundamental quantity, because that's to do with value, right? It has to do with how we perceive Bitcoin as value. And so I found out that there is a very, very precise, beautiful relationship between price and time. So simple that actually you can write one line equation to describe the majority of a Bitcoin behavior. And that behavior is a power law. Eventually I went from that discovery, so I posted on Reddit. I didn't have a lot of, some comments, but and some upvotes, but it didn't have the impact that I thought. I think it influenced people like Plan B, for example. I think I actually read my article, and he was influenced by this post to create his S2F model.
So how long ago was this initial Reddit post, if you don't
was,
mind me asking?
This was 2018. Post, so while I started to study Bitcoin scientifically in 2012, the Reddit post is in 2018. It was in 2018. And then, you know, some people took it like this guy H.C. Berger took my article and started to make it a little bit more popular. So it started to spread, the idea started to spread around a little bit more. But it was not as popular as recently, because one of the breakthrough was that this financial influencer called Andrei Jik, he actually saw my more recent post, because I made an update after 5 years of a power law being around and making a prediction, because I basically say, okay, this is what is going to happen in the future, you know. So I made a projection of where the price was going to be. After 5 years, say, you see, I was right. But it's kind of crazy, right? You actually work in the field of using math to understand markets and things like that. And it's almost unheard that somebody can make a prediction 5 years ahead about any asset at all, right? And I was right, because now once we go through the slides, you will understand right in which way, right? It's the power law gives us this fair value, the general trend value, but I was still right. So it's still amazing to be able to say, hey, in general, the trend price for this asset 5 years ahead of us, gold or anything, will be this, right? And with Bitcoin, it's not a small deal, because Bitcoin changes a lot. It's kind of easier with gold because it doesn't go anywhere, but with Bitcoin, that goes very fast, knowing 5 years ahead what the general trend is pretty amazing. And it's not about me. This is what I'm trying to say all the time. It's about Bitcoin, how beautiful and regular Bitcoin is. I just trying to understand it from the right point of view. And so from that moment, and then, you know, that post got much more attention, because now it was based on a previous prediction, and people could compare and were impressed about that. And this Andrei Jik, he contacted me. He has millions of people watching his YouTube channel, so we did a video, and since then I exploded in popularity, and the theory also exploded in popularity. I didn't have even a theory at that time. Actually, the theory is very recent. It's actually this year, and one of the reasons is actually my interaction with the public, and with in particular the Twitter community, because I started to interact with them, got a lot of questions, a lot of interest, a lot of some people, you know, a little bit more critical, some people, even some trolls, but the majority were very positive and very supportive, and this interaction actually made me work harder and think harder about what all this meant. And finally, I got the entire picture, to the point where I claim that this theory, that and there is a reason why I call it a theory, and that I will explain in a moment, is really basically like cracking Bitcoin code. I really think if not in everything in the details, because there is still room for other scientists or other thinkers to come and work under this framework, it gives us like really a big and very important fundamental framework on the nature of Bitcoin, why Bitcoin does what it does, where Bitcoin is going, how Bitcoin interacts with the world, with the financial world, with many different events that are happening in the world. It's really a powerful, powerful theory. So what the theory tries to do? Well, first of all, it's this idea that I want to understand Bitcoin from a scientific point of view. And I have this picture to explain that, because it's like this star or this thing in the sky that the scientist is studying using a tool of a telescope, so scientific tools, and he's in these robes, in these Renaissance robes, to signify that it's almost like a revolution, like very similar to the Copernican revolution. When Copernicus was around, was this Renaissance time, right? We went from the Middle Ages to the Renaissance. We were other scientists like Galileo and so on. And the idea is that everything that happened before in understanding Bitcoin is almost like the geocentric system. So it's basically like a revolution. We are changing the way of thinking about Bitcoin using these tools of science and mathematics, and also shifting a little bit the attention to certain things that people think, like, for example, one of the big results of the theory is that scarcity really doesn't play a role in how the price reacts in Bitcoin. It has to do with other things that we'll show in a moment, mostly adoption and the fact that that Bitcoin is a network, and scarcity, or basically when you look at the data, almost plays no role at all. Now, this is different from the cap, in Bitcoin having a finite cap, that is a very fundamental property, and I will never argue against it. But the fact that there is supply shocks and other things like that, we will see that has no role in Bitcoin. So this is kind of a slide to emphasize this idea that this particular approach tries to focus on the science, is trying to focus on data, and also trying to kind of revolutionize a little bit our understanding of what Bitcoin is. And one of the first things that I always show in trying to introduce these ideas is this chart. This chart shows the price of Bitcoin in what is called a linear chart. The chart has the price on the y-axis, as the days in the x-axis. This is the unit of time that we use when we study Bitcoin in this particular manner. These days are the days from what is called the Genesis block, is when Bitcoin was created. That is January 3, 2009. So when I say 2000 day, it means 2000 days from January 3, 2009. It makes sense because if you want to describe a behavior of a system, it makes sense to talk about from the time when it was created, when this particular system was created. You can also put dates in the bottom, but usually when we discuss these charts, it's all in terms of time from when Bitcoin was created. What you see about this chart is that it's a very, very volatile asset, right? So it started, if you look at almost until day 1500, the price was so small in comparison with recent price action that looks almost flat, right? You are not even able to see anything there. It looks like a flat line. And that is several years, right? For several years, basically, in comparison with the price right now, the price look almost nothing. And then you see these big bubbles, right? What we are, as Bitcoiners, are very aware of it. There are these bubbles. During these bubbles, the price goes up a lot, then it crashes, and it goes down. There is some period in between. When there is another bubble, the price goes up even more, and then crashes really violently. Sometimes 80% of the time, almost goes back to zero, right? And then it grows again, and so on. So the bottom line, this is the chart that usually they show on TV, when on CNBC, on other financial shows. It's mostly they do that to emphasize how volatile the asset is, how unreliable it is. Most of the shows are not supportive of Bitcoin, and so they want to make a case that is a very unreliable asset, very volatile asset, and so you will not put your life on it, right? You will not sell everything like sellers recommends, sell your shares and buy this thing, because yes, the general trend seems to go up, but this volatility is so big that one day it could crash all the way to zero and not recover, right? Many people still think that, right? And so it's not a very useful chart. And so in science, many times when we understand a phenomena, right, we want to plot data between two quantities. Like I want to study this quantity versus this other quantity. I don't know, pressure of a gas that I'm studying versus a volume, right? So I'm making a graph and then try to see if there is a relationship between these two things. And the simplest possible relationship that we would like to see is a straight line, because straight line, human beings like straight line. We recognize straight line. It's easy to describe the behavior. It's what is called a linear relationship between two quantities. If we don't see a linear relationship immediately, many times we go, in particular when we see that what we are studying spans many order of magnitude. So order of magnitude means things that change by a factor of 10. So I have 10, 100, 1,000, 10,000, and so on. If I see something that changes like that, I like to use the log in the y-axis. So this is the graph that you're seeing here. In this case, you can see now that the area that was flat before, it's visible. It's easy to see. And also, the other thing you see, so forget for a moment the rainbow bands. If you look at the general path, that is the black line, the star represents the halving, by the way. So you see that the path is much more regular, right? So that thing that you see before when it goes violently up and down is much more organized, much more tame, right? These bubbles, they don't seem so huge as before. In fact, they look comparable before, right? Before they look like one was much bigger than the other, etc. Now they seem to be whole kind of proportional to each other. And also there is this general trend that goes up, right? Kind of flattened out. It looks like it's flattened out, but it in general goes up, right? So you will say, this is very interesting asset because yes, there are these oscillations, but in general it goes up, and it goes up. It doesn't seem it's going to crash at any moment, right? It's a very different picture. So this type of graph is called a log linear graph, because you have a log on the y-axis, and the x-axis remains linear. Now, let me explain for a second what a log is, okay, if you don't mind, because maybe some people need a little refresher. So it's a very simple mathematical function. One way to think about functions in mathematics is like a little box, right? So you put in something in the box and you get something out, right? So one way to understand these type of things, like the price in Bitcoin, when the price spans a lot, is what this thing that is called the scientific notation. So we can write numbers. In science, we like to write number when we are playing with this big, huge number as powers. So powers means I'm writing a number like 10, let's say, and then I raise it to a power, let's say 2. So that 10 to the 2 is a way to expressing 100. Why? Because 100 is nothing else than 10 multiplied by 10, right? 2 times. So if I multiply by 2 times, when I write that little exponent, 2, that means 10 times 10. So if I have 1,000, then I have 10 times 10 times 10, and that number will be 10 to the 3. If I have 10,000, I will have multiplied 10 by itself 4 times, 10 by 10 by 10 by 10. I get 10,000 or 10 to the 4. And you understand how it goes. If I have a number below 1, it means 1 over 10, so I can write it as 10 to the minus 1, for example. So once you understand this scientific notation, it's easy to understand what a log is, because I can take 10 to the 2, that is 100. I can put it inside my little box that I described before, and it spits out the exponent. So you put in 10 to the 2, it gives me 2. You put in 10 to the 3, it gives me 3. You put in 10 to the 4, it gives me 4. So this is what the log does. It takes the out from the number, the exponent that number is expressing, right? So, for example, here in this graph, if we express the price in terms of logs, and this kind of log is called log of 10 because all the numbers are expressed as powers of 10, then 10 to the minus 1 will be 0.1, right? So basically 1/10 of $1. This when Bitcoin. So this chart shows the price of Bitcoin when the first market started to open. Of course, Bitcoin had already 1 year of history, but usually we don't have continuous data, at least for the price, before that. So this is usually where we start. Remember, it's always you're always implicitly including the start of Bitcoin because all the time is described in terms of time from the Genesis block. But in terms of showing the data, here where we have this cutoff, right? And Bitcoin was just a few cents. It was less than $1. Then eventually became $1. This 0 means $1 because 10 to the 0 is 10 to the 0 is 1, and then $10, 10 to the 1, $100, $1,000, and so on. The beauty of doing it in this way is that now we emphasize all these changes in scale in a proportional way. So this is why you can see the small little changes in the price when the price was small and when the price was big. They seem kind of proportional to each other, right? So it's a very good way of showing something that changes in time by a big amount, like Bitcoin did, right? It went from being a small little fraction of $1 to almost $100,000 recently, right? And so there is much more regularity, much more. It looks much more something that you will trust, right, over time. But it's still there is like the question of, okay, if there is a pattern and that kind of rainbow type of shape, it's a pattern, what is this pattern? And there are mathematical tools where you could try to say, okay, is it this function, is this other function? You can try many different things, but it's a little bit unsatisfactory because the human eye likes to see straight line, right? So it will be nice if there is a way of making this thing look like straight line. We're going closer and closer, right? Because right now it looks much more regular. It's not yet a straight line, yeah. So it's what most people have seen, because almost every Bitcoiner has seen a version of this chart somewhere, right? This thing that seems to follow a general pattern, but for a long time people didn't know that there was one single function that actually can describe this behavior. So in physics we are trained to do the next step. And by the way, one thing I want to say is that if Bitcoin, so one very particular function that comes sometime in data in general, but also sometime in financial assets, is what is called an exponential. So an exponential, if you have any process that double itself on a regular fashion, imagine, for example, some virus or some bacteria inside a petri dish. These bacteria reproduce themselves, they double themselves, they do it in a certain rate. Different bacteria do it in different ways according to also to how much food we have available. But let's say we do it once every day. So once every day they double. So over time, this behavior, if you plot how many bacteria there are in the petri dish, will look like this very fast growing hockey stick. That is called an exponential. And an exponential in a chart like this will look like a straight line. So if we add this is why you do this step also, because remember we would like to see a straight line because it's one of the simplest relationship between data. And so if a Bitcoin was an exponential type of function, it will look like a straight line, a graph like that. And evidently it doesn't, right? It looks curved. And so this curving actually is a little bit of an illusion, because if you go to the previous graph, Bitcoin looks like it's going up, right? It's curving up. And so how come it looks curved down here? Simply because this graph will show an exponential as a straight line. And if it is not a straight line and it grows slower than this exponential, it's going to look like it's losing ground. So it's kind of an illusion of a graph, an artifact of a graph. But it's still growing pretty fast, but not as an exponential. So the next thing that we do in physics that is very, very usual for us, but even for me it took a longer time because I did this graph, this type of graph for the other things like price and addresses or transaction and price, other things like that. It didn't come to my mind to do it with time because it's not that in physics we don't do it with time. I didn't expect that an asset, even Bitcoin, that has all this irregularity, will be what the straight line is when you find a straight line in this graph. It is called a power law. So I didn't expect to be a power law in time, and so it took me some time to actually do this, but eventually I did. And this was actually the main breakthrough because it has many consequences that I will explain in a moment. But this type of graph is called a log-log graph. So you have a log of y and you have a log of x. The beautiful thing about this is, and this is why we do it in physics, that many phenomena all around us show up like straight lines in a graph like this. And there is a mathematical reason for that, and that's relatively simple. But first of all, I want to, before we go there, I want to show you why I claim it's a straight line. So I know that it doesn't look like a straight line in the sense that it still oscillates, right? It's not like completely flat like a straight line, so that is important to emphasize. But you can see now, right? It's a very different graph from this, or from this. Or from this one, right? Where it's not anymore some kind of arbitrary curve. It's something that is very striking, right? It's almost like shocking in a way, right? To see Bitcoin as a very precise straight path like this, right? For example, we show this graph in this show called What Bitcoin Did. That is a very popular show, and one of the host called it the graph that you cannot unsee. So it's pretty striking, and when I saw it the first time, I was kind of shocked because I saw, okay, this means that Bitcoin is even more regular than I thought, right? Do you have any question on this particular graph? Do you have any observation, or do you want to ask any particular questions about? Does it look straight to you, like the Bitcoin price in general looks much more straightforward in relatively to other type of graph?
It does, yes, absolutely. And this compared to other graphs, maybe you're getting to it, but I think we could take a pause here and explain the difference between the power law phenomena and pure exponential growth, and why the Plan B model is invalidated and isn't correct, whereas the power law phenomena is much more sustainable. I think my question would be, and it would be helpful for the viewers, why are exponential functions so unsustainable versus power laws, which are really robust, anti-fragile, and sustainable?
Right. Yeah. So the first thing that I will say, right? So because maybe a simple graph is not something that convincing to most people, is that these graphs are not easy to get. In particular, what you want to notice is that the span of magnitude that Bitcoin is covering, it's enormous. It goes from 10 to the minus 1 to basically 10 to the 5. It's 100,000. So we are not quite there, but basically we are close to that. When for example, we had this peak at close to $70,000, right? And we are very close to 100,000. So this is one of the first things that we want to notice in terms of understanding power laws, because power laws are phenomena that usually span many orders of magnitude. And in a moment I will show you a graph where I show you how common these power laws are. That is one of the most important things we want to understand, that power laws are not any other kind of type of function. It's not like, oh, this could be an exponential, this could be a power law, this could be some sine wave or whatever. Power laws are actually kind of a key to understand the universe. So if you have a phenomena that behaves like a power law, you pay attention as a physicist, because so many things in nature behave like power law, but also the nature of what a power law is, its characteristics, like you were mentioning, the fact that they are very stable, that they are anti-fragile, all these important characteristics about power laws come from the nature of the phenomena that causes power law. There are very precise processes that generate the power laws, and the idea of a process is something that requires some level of feedback loops. So if you have any system that has a lot of feedback loops, if that is part of understanding why they are anti-fragile, systems that take the input and then the input becomes the output again, and you have a cycle of feedback like loop like that, they tend to adapt and regulate. For example, this is why physiology, a lot of the physiology of organism, including ourselves, are expressed through power laws. A lot of the property, if you look at how an animal grows, how the metabolism of an animal works, a lot of these properties of organism follow power laws. And that is due to the fact that there are a lot of parts interacting in an organism, for example, the cells, and when you have these parts interacting with each other and exchanging information, materials, like food, etc., they tend to organize themselves to minimize energy, to optimize processes, and so on and so on. All these interactions over time tend to optimize themselves. So it's because what creates the power laws, that is these interaction processes, make them robust. So for example, if you are pushing an organism out of its balance, there is this thing called homeostasis that tends to bring back the system to its original balance, right? So for example, if I run and my heartbeat starts to go up too much, then I start to feel not good, I want to rest, and then the heartbeat goes back to its general function. So that is very typical of all these. This is why we find it so many times in nature, because if there is some kind of process that is based on interactions between the elements of that system, then you will see power laws. And in fact, I always say, once I did the discovery, of course you have to do the discovery first, that it would have been weird if we didn't find power laws in Bitcoin. Because if you think about how Bitcoin works, this is why I'm saying this is much more than a theory. It's much more than a model. It's a powerful theory about what Bitcoin is. It's one of the systems that has all these properties, all these iterative processes, or these feedback loops. There are feedback loops everywhere, right? So for example, let's take hash rate. Hash rate, because of a difficulty adjustment, is one of the things that people don't always think about Bitcoin, because Bitcoin is not just an asset.
And for the viewers, really quick, you're going into now the other parts of Bitcoin that showcase a power law dynamic. Now, it's not just the price and time that demonstrate a power law, but it's these other components of Bitcoin too.
Correct. And I mentioned hash rate is simply to make a point of this iteration that we see everywhere in Bitcoin, right? Because probably it's one of the easiest to understand. In the case of the hash rate, we have this thing called the difficulty adjustment. I don't know if many viewers know, but it's important to understand that Bitcoin is not just an asset where people buy and sell it or whatever. It's not just an idea that you want to accept, the fact that has a finite cap, all the characteristics of Bitcoin, right? That is a digital asset, that you can transfer it, that you can own it on your own computer, and you don't need a bank, all these ideas that are associated with Bitcoin. But it's also an algorithm. It's an algorithm, right? That is based on math, it's based on calculation, it's based on things that information that computer transfer, and there is this mechanism that is included in the code that regulates how much computational power the system has, because if it goes too high, that affects how long it takes one of these blocks to be resolved that are part of the Bitcoin algorithm. And then there is this component of the algorithm that increases the difficulty. Because how Satoshi built Bitcoin it almost like if you want it to be a power law, because by the time you introduce something like the difficulty adjustment, that is one of these feedback loop that I mentioned, right? Something happens, and that is your input, your output. You take the output and you make it an input, like in a feedback loop like that. You will get a power law. So even if Satoshi didn't maybe think about, oh, I'm going to create a system that is regulated by power law, by introducing the difficulty adjustment, it contributed to that. But there are others, right? So for example, the adoption, it's a feedback loop, because the number of Bitcoiners right now is influencing the number of Bitcoiner next, right? More of us are talking about Bitcoin, more of us are discussing Bitcoin with friends, with family, with people that we just met, and that affects how many Bitcoiners will be next, right? And so on, in a feedback loop. So again, another feedback loop. Almost everything that has to do with Bitcoin, the price itself, right? If there is a higher price, that attracts more people, right? Because people are getting FOMO and they want to join in, and so on. So if you have a system like this, where the current status of a system affects its future status, you will get power laws. And so the amazing thing is the main component, right? One of the things that most people pay attention, the price, it's a power law itself of time. And it turns out that the power law in general, what is a power law? Because we are using this term all the time. So let's define it in a more precise way. The power law, it's a simple relationship between two quantities. So we have y and we have x, right? In a graph, when we describe a relationship between two quantities. And the simple relationship that we mentioned so many times is this straight line, right? So the straight line that we observe in this log-log graph is really not a straight line, because it's in this weird type of graph that has the log of y and the log of x. Now, it's relatively simple mathematics, and if one follows my channel or goes on my YouTube channel, we have videos where we go in the details of that. But it turns out that if you see a straight line in that type of graph, it's really an equation of this type. It's an equation where you have y and then you have x, and they are related by a power. So the power will be, you are raising the quantity x to some number. So a very famous power law that everybody knows, it's the parabola, what we call the parabola, right? Parabola is nothing else than y equal x squared. So you never heard about a parabola being a power law, but it is a power law. But anything, it doesn't have to be 2, it can be 3, it can be any number, but n can be any number. It can be even a negative number. If it is a negative number, then it will go down instead of going up. If it is a number less than 1, it will start to kind of flatten out, for example. In the case of Bitcoin, that number is something close to 6, is 5.83. And that constant A, it's a very small number. And how do we get these two numbers? Well, we get it from that straight line. When you get there is a mathematical tool called regression. You apply this regression. Is basically a way of finding what is called the best fitting line. So you're looking at the smallest distance of all these data points from a line. And then the algorithm that you're running on your computer using the data gives you two numbers. It gives you the y-intercept of this straight line, that is this A, and it gives you the slope that turns out to be the exponent. So you can show with relatively simple math that these two numbers that identify the straight line in the log-log graph, that is the slope, and the y-intercept are nothing else than this constant and this exponent. The most important number here is really this exponent. So remember, it's something close to 6. First of all, what is the consequence of that? So, well, even before that, notice now that we have a very, very simple formula that describe the behavior of Bitcoin. So first of all, what do we mean with the behavior of Bitcoin? Well, we mean it in this very special way of being, so forget for a moment this sine wave that we can discuss. It's basically an attempt to show also that beside the general trend of Bitcoin, that is this straight line, there are also these obvious oscillations, right? And I didn't include this first bubble because this bubble is actually an anomaly. When you compare it with the other bubble, it doesn't behave in the same way. These bubbles are very periodic. They happen at a very precise timing. This bubble doesn't. So I still trying to, I would like to understand the nature of this bubble. I think it was due to some manipulation of the market initially when Bitcoin was very small and whatever. But it's something that it needs to be understood. But the other bubbles are very clearly associated with the halving. They happen at very specific times after the halving. They are very regular. And so we include them in this model. So I have a model where I can also add as an addition, right, the bubble. So there are basically two phenomena. To understand Bitcoin, there are two main components. One is the general trend, that is basically this orange line. So there is a straight line in this log-log graph. And then there are the oscillations, these oscillations that are associated with the bubbles. But the general trend, what is amazing about this general trend is that it's a simple formula. That is amazing, right? That you have something complex like Bitcoin that can be simplified by one of the easiest equations. It will be even easier if it was a linear relationship, but it's the second simplest thing after a linear relationship, a power law. Because when people hear power law, they think it's this very complex thing. It's simply I'm telling you there is one quantity related to another quantity to the power. You know, it could be the square, it can be the cube, whatever. In this case, it's 5.83. You know, but that number is really close to 6. So one way of thinking about Bitcoin, that is a process that changes in time with the 6 of time, with the 6 power of time. What does it mean? Well, it means that, let's say we double the time that Bitcoin existed, right? So right now, Bitcoin existed for 15 years. So let's say we go 15 years in the future, so we double the time that Bitcoin existed. So we take that 2, that is how much time is passed by, right? 2 times. And then you take the power of 6. The power of 6 of 2, it's 64. So this is how simple it is, right? You can say, how long Bitcoin existed? Okay, let me double it. Let me go 3 times. And then you take that change 2 times, 3 times, and then you take the power. So for example, the power of 2, if I take 2 to the 6, it gives me 64. So it means that in 15 years from now, the price of Bitcoin will be 64 times larger. So if right now we have about 60,000 Bitcoin, $60,000 Bitcoin, you multiply that by 64, you get something close to $4 million. So it's incredible that we could make a prediction like this and say, hey, in 15 years from now, the math of Bitcoin, if this math continues, shows it should be around $4 million. We know, not exactly, of course it could be $1,000 more, $1,000 less, it could happen a few days later, a few days earlier, but roughly 15 years means 64 improvement. Now, what about 3 times? So if I go to, instead of 30 years, a 45 years history of Bitcoin, right? So I multiply 15 by 3, I get 45. What about 45 years, right? A total history of 30 years from now. Well, you take 3, you take the power of 3 to the 6, you get something crazy that is 720 times. Okay, so the price will be 720 times larger than now, and you can do the math in your head of what that means. It means many, many millions from now, right? But it's more difficult to extrapolate this prediction to 30 years versus 15. 15 is something that we can trust for several reasons. One of these reasons is another very fundamental property of power law, that is this idea of scale invariance, which I will describe in a moment.
Hey everyone, it's Joe here. I hope you enjoyed part 1 of my interview with Giovanni. It's an absolute insanely dense interview. So I split it up into 2 parts. The next part will be going live next Wednesday. So make sure you follow, hit the post notifications, and of course, download Theya. What are you waiting for? Check it out. Simplified Bitcoin single sig or multisig self-custody. So easy your grandma could do it. And I'll talk to you guys soon. Thank you.